today's video, we are talking about the interior angles of polygons. So our learning target today is I can find the sum of interior angles on a polygon and use that to solve problems. Write down the date you're watching this and then write down what you already know. So in this case, the word sum of interior angles on a polygon, well, you know what sum means. You know what interior angle is. And you know what a polygon is. So that's a lot of things that you know already that you can write about for your I know. And then we have no vocabulary today because we had enough for our last video. So pause the video while you get all that written down and then restart when you're ready to go. When we talk about the sum of interior angles, the interior angles of a polygon are the angles inside of a polygon. So for example, on a triangle, we know that the three angles have to add up to 180. Whatever these three angles are, they always add up to 180 degrees. So the fact is that we can actually use this to go a little further. So let's look, for example, at a quadrilateral. So I'm going to draw a trapezoid here. And the way to figure out how many degrees are in the interior angle of a quadrilateral is by drawing diagonals. So what I want to do here is I want to split this up into triangles because I know how many degrees are in a triangle. So if I can figure out how many triangles this gets split into, then I will be able to figure out how many degrees are in the shape. So let's say I look at this corner right here, and I'm going to start one quarter and I'm going to draw all of the diagonals. Remember, diagonals don't go along the side length, so that's not a diagonal. And this would not be a diagonal either. My only diagonal is going to be to that point there. Here I see that I have two triangles. Each of these triangles has 180 degrees in it. That means that in the quadrilateral, my sum of my interior angles, if I were to add up all of the angles, they would add up to 180 plus 180 because I split it into two triangles. So 2 times 180 for my quadrilateral, which is 360. The fact is that all quadrilaterals have their interior angles will sum to 180. All of them. So no matter if it is a parallelogram or a square or anything else, it will always add up to 180. So let's see if we can make this work for some other shapes. So let's draw a pentagon. If I draw a pentagon, again, I want to be able to split it into triangles. So if I start at one corner, and I'll pick that one. You could pick a different one. You could pick this corner or wherever else. But pick one corner and see if you can draw diagonals to split it into triangles. Restart the video when you're ready. So when I draw this, I start one diagonal here, draw another diagonal there, and I have three triangles, each of which has interior angles that add up to 180. So three triangles, each of them add up to 180. That means that the sum of my interior angles is 180 times 3, which is 540. Okay, let's try a hexagon. A hexagon has 6 sides. So here's my hexagon. So once again, pick one point. It can be any point. And see if you can draw all of the diagonals, pausing the video here. And see if you can figure out how many degrees are in the interior angles of a hexagon. Okay, so hopefully you've tried this. If I draw my lines, I'm able to draw to those places. So I have 4 triangles this time, each of which I know that the corners add up to 180 degrees. That means that the sum of my interior angles is 180 times 4, which is 720. I could keep going. So let's do one more. Let's do a heptagon. So a heptagon is a 7-sided figure. It starts like a little house, and then at the bottom, we go like that. Once again, please pick one corner, draw your diagonals, and see if you can figure out how many triangles it is. So I can draw diagonals, all of those. Now, one mistake some people get will be that they will say, okay, well, if I'm drawing diagonals, well, I can also draw a diagonal here and a diagonal there. And suddenly I have a lot of shapes happening. Or they'll say, oh, well, here instead of my last diagonal, I'll draw a line like that and a line like that. And suddenly we have tons of diagonals happening. To draw our diagonals for this, we need to start at one corner and draw the lines to every other corner. If you're drawing lines all over the place, you're going to end up with a lot of extra triangles. So in this case, I have 5 triangles. So my sum of my interior angles is 180 times 5, which is 900. Now you may be noticing a pattern. A 3-sided figure is 180. 4-sided, we did 180 times 2. 5-sided is 180 times 3. 6-sided was 180 times 4. 7-sided is 180 times 5. So you may be noticing that there is a pattern. And the pattern is actually our rule. So the rule is that for all polygons, the number of angles, that is the sum of their interior angles, is the number of sides minus 2 times 180. And this is for all polygons. Anytime we find a polygon, all we have to do to figure out how many degrees are in its interior angles is we take the number of sides. So like our heptagon here has 7 sides. So for 7 sides, we do 7 minus 2 times 180, or 5 times 180. That's exactly what we got by drawing triangles. So either way works. We can either draw triangles or we can use this rule. But the rule works even if, for example, I told you that we had a 12-gon, a 12-sided figure. The 12-sided figure, the sum of the interior angles, we could just use the formula of drawing the picture. So the sum of my interior angles would be 12 minus 2 times 180. That's 10 times 180, or 1,800. Now, the reason we care about that is that it's going to let us solve problems. So let's say we were looking at this shape right here. Looking at this shape, if we wanted to find the sum of interior angles, the first thing I want to know is how many sides this has, which is 1, 2, 3, 4, 5. So this has 5 sides. So we do 5 minus 2 times 180. That equals 3 times 180, which equals 540 degrees. That is the sum of the interior angles. So now I know that if I add up all of these numbers, that should equal 540 degrees. Well, in this picture, all of those orange angles, one of them, I don't know. I don't know what x is, but I know that all five together have to add up to 540. So if I were to think about how I would find x, I would say, okay, I am at 105 plus 118 plus 75 plus 130 plus x, that has to equal 540 degrees. I got those numbers from those orange highlighted angles. So now I can just take my calculator and do 105 plus 118 plus 75 plus 130. That gives me 428 plus x equals 540. So to find x, I just do minus 428 from the 540, and I get that x equals 112 degrees. This is the most important part of the finding the sum of the interior angles. And this is what your homework and quiz are going to look like. So first, finding the sum of the interior angles. That involves counting how many sides there are and figuring out how many degrees it all has to add up to. So if I count, I have 1, 2, 3, 4, 5, 6. This is a 7-sided figure. Now I can use the formula. 7 minus 2 times 180. That's 5 times 180, which is 900 degrees. That's my answer for the sum of the interior angles. Now, the last thing I can do is add up all of the angles here and see what's left over to get x. So this is your problem that you're going to do for your polygons check. I would like you to see if you can figure out what x is, just like we did in the above problem. Add up the angles that we know, the 130, 132, 130, 130, 128, 138. Add that all up together, subtract it from 900, so you can figure out what x is and enter that into Schoology for your check. Let me know if you have any questions or need any help with this. Thanks so much and have a great day.